Hello, this is going to be a lesson on scalars and vectors for the OCR physics course. This is 2.3.1. So this is what we're going to be covering today, and here is why I'm doing this video. I aim from this series to further my own knowledge of the OCR A-level course, as well as physics in general, and also to help other people who want to further their learning and just recap over what they've already learned as revision, so they can do better in the exam. So this is going to be on a very simple topic today, scalars and vectors, and this is what we're going to be covering: scalar and vector quantities, vector addition and subtraction, vector triangle to determine the resultant, and resolving a vector. So this is sort of an introduction video. I can do more topics such as Archimedes' principle or things on circuits, Kirchhoff's first law, anything like that, but this is just a simple topic, just an introduction, so I can get used to the format of how these videos are going to be. So first of all, on the topic of scalars and vectors, you have to look at what a scalar quantity is and what a vector quantity is. So a scalar quantity is any quantity which just has magnitude. That means a quantity that has size, so it can be distance in meters, time in seconds, and speed in meters per second. You'll notice these quantities can all have different units, but none of them have direction. So that's what a scalar quantity is. In an exam, they can definitely ask you that, a 1-mark question, I'm pretty sure, and just say what is a scalar quantity, and that's the definition: a quantity which just has magnitude. As opposed to that, you have vector quantities, which are quantities with both magnitude and direction. The direction can be expressed as a cardinal direction, northeast, south, or west, left or right, or as an angle from the horizontal or from the vertical. Vectors are used for many different measurements, all of which obviously have a direction. So that could be a force acting on a car acting westwards, or anything like that. It could be a pulling force at an angle of 30 degrees on an inclined plane, for example. You've got the magnitude, which is, for example, a force having 10 newtons, and then acting at an angle of 30 degrees, that's the direction, and that would be a vector quantity. So the next thing you need to know is how to add and subtract vectors. This is very simple. You can only add or subtract vectors if they're parallel to each other or anti-parallel. Anti-parallel is when two vectors act equal but opposite in direction. Two or more parallel vectors can be added together to find the total resultant vector. The resultant vector is a single vector which has the same effect of all other vectors acting at a point combined. So parallel vectors which act in the same direction are simply added, and anti-parallel vectors which act in opposite directions, you subtract the two vectors. Very simple. So you can make notes on this or whatever. Okay, so here are some examples. If you have a 3 Newton force pushing an object and a 5 Newton force pulling the object, then the combined resultant vector will just be 8 newtons. You simply add them, and if it adds in opposite directions, then you choose one of the directions to be positive. So I've chosen this direction to be positive, so I do 5 minus 4, and you get the resultant of 1. So that's very simple. And for adding vectors, there's nothing harder than that if they're parallel. The next topic is finding the resultant vector. So as already mentioned, the resultant vector is a single vector which has the same effect as 2 or more vectors acting at a point or acting on an object or whatever. So if 2 vectors are perpendicular to each other, a resultant vector can be found simply using Pythagoras. Pythagoras' theorem is a squared plus b squared equals c squared, so the 2 perpendicular vectors will be a and b, the resultant will be c, and you can just form a vector triangle to find the resultant. You have to make sure though that the resultant vector goes from the start of the first vector to the end of the second. Okay, so then to find the angle which the resultant vector acts, you can just use trigonometry, and I'll show an example of a question like this on the next slide. Okay, I have no idea why I did that. So for 2 perpendicular vectors like the one below, you would expect that the resultant force So the combined effect of both of those forces would just act diagonally, but you don't know the magnitude of it and you don't know the exact angle at which it will act. So to do this, you can just use Pythagoras and trigonometry, and you form a vector triangle. So I'll show you how to form a vector triangle. So if you have two perpendicular forces like this, and you have a resultant force acting diagonally, then you can take the resultant force like this, take one of the perpendicular forces, join it to the other perpendicular force like that. So it goes from the start of the first up to the second, straight like this. So very simple to do, and you can see you formed a triangle, right angle triangle, and you can just use Pythagoras. So we have the angle there. To find out what the f is, we just use a squared plus b squared is c squared, 3 squared plus 4 squared equals c squared, 25 equals c squared, c equals 5, and then you can just use trigonometry. You know, tan x, where the angle is x, is opposite over adjacent. Tan x is 403, using the inverse of tan. You can find that the angle is 53.13 degrees. So resolving a vector is the opposite of finding the resultant. When you find the resultant, you take two perpendicular vectors and you find out the combined effect of them. But resolving a vector is taking a single force or vector and splitting it into its two horizontal and vertical perpendicular components. So I've written in here that any vector that acts neither horizontally nor vertically can be split into two different components, one that's horizontal and one that's vertical. There's an easy way to remember this. An easy way to remember this is that if you go through the angle, you use cosine, and if you go away from the angle, you use sine. So I'll show you an example of this. So if we have a force, this is essentially a resultant force acting on an object, and we'll call it F. Then to find out the horizontal component, you're going through the angle like so. You're bringing this down, putting it down, and you're going through the angle, then you use cosine. So it'll be the resultant force times the cos of the angle, and if you're going away, bringing it away to find the vertical, you're doing f sine x. So remember, cosine equals through and sine equals away. So I'll show you why this works. It's very simple. It just uses basic trigonometry. So if you wanted to find this horizontal, you'd have the horizontal like this, you'd have this like f like this. We'll just call this length A, and we'll call this angle X. If you want to find out the horizontal component, you would use cosine because you have an adjacent and you have a hypotenuse. I can show you a different colour, for example green. Imagine this was a full triangle. Then you'd have, to find out what A is, you'd use cosine of X equals A over f cos x equals a, where a is the horizontal component. That's how you resolve a vector into its two components. Through is cosine and away is sine. Always, that's always the case. So now I'm going to take a more complicated situation. So if you have two vectors which are not perpendicular but they both act at angles, or if one of them acts at an angle and one of them is either horizontal or vertical, then you can't just form a vector triangle because you won't have a right angle triangle. It will be an angle. So instead, to find this, you can split each vector into its horizontal and vertical components, and then you add or subtract either in the horizontal direction and the vertical direction, and then you use Pythagoras on the two forces that you get out of this. So I'll do an example of this of two forces. We'll say that one of them acts like this, and it is 3 newtons, and we'll have another one in a different colour acting like this. We'll say it's 4 newtons, and then we have the horizontal here, and it makes an angle of 30 degrees. You can see here you wouldn't be able to form a vector triangle. If you want to find the resultant of these two vectors, even with the resultant, it wouldn't form a right angle triangle. It would form a different triangle, and there is a different method you can use to find out this, where you use the cosine rule or the sine rule, but I think this method is a lot better. You split each vector into its horizontal and vertical components. So this one is already acting vertically, so I don't need to split that at all, but this one is acting at 30 degrees from the horizontal, so I'm going to need to split this one into its horizontal and vertical components, because every force that acts at an angle will have two different components that make up the force, horizontally and vertically, and that's exactly what we're going to find. So we're going through the angle, so it will be the force times cosine 30. So this is for horizontal, by the way, so I'll just draw a little arrow here, which means horizontally. We have 4 cos 30, and that's the only forces we have acting in the horizontal direction. This force only acts vertically, so we don't need to resolve it. So that's horizontally, and then vertically, we'll just do that in a different color. Vertically, we have 3 newtons, so 3, plus the force, and we're going away from the angle this time, so we use sine, plus 4 sine 30, and that equals the total vertical forces in this example. So 4 sine 30 is 4 times a half, plus 3, so we're going to definitely have 5 newtons, and here we have 4 cosine 30, which is cosine 30 is so we're going to have 2 root 3. So we have here, forming a vector triangle, we have a 5 newtons across and 2 root 3 newtons vertically. And now we can form a vector triangle and use Pythagoras to find the resultant. So find the resultant of this, the resultant will look something like that. And we can form a vector triangle. And we have this one comes up here. And this one comes over here like this. So this is 2 root 3. This is 5. Using Pythagoras, 2 root 3 squared plus 5 squared equals c squared. So here we have 2 root 3 times 2 root 3 plus 25 equals c squared. 2 root 3 times 2 root 3, we do root 3 times root 3, which is 3. 2 times 2 is 4. 4 times 2 is 12. So 12 plus 25 equals c squared. And then we've got, bring us over here, we have 37 equals c squared. C equals square root of 37. So that has been the end of this lesson. Thank you for watching. It's been on scalars and vectors, how to resolve them, how to find the resultant, and what they are. Thank you for watching, and goodbye.